we're back. Okay, so I to the fourth.
Isn't that just
Any idea what I to the fourth would be? Any guesses?
-1.
Yeah.
Not -1. I squared's -1.
What about
Positive 1.
Why is it +1?
So it's negative 1 times negative.
Where'd you get -1 from?
I squared.
I to 4 is I squared times I squared. What's I squared?
No, negative 1.
-1 times -1 is +1. Very good. Okay. Any idea what I to the fifth is?
Negative.
Hmm? Why is it I?
Negative 1.
I to the fifth, would you agree is the same as I to the fourth times I? Because I is I to the what? 1. What's I to the fourth? 1 times I is I. What's I to the sixth?
I squared?
Which is what?
-1.
How'd you get that -1?
I3 times I3.
You could do I 3 times I 3, or could do I 4 times I 2. I think that's easier. What's I 4?
1.
1. What's 1 times I squared? I squared. And what's I squared? -1. What's I to the 7? Very good. How'd you get negative I? Who said that?
I don't know, I just went with the pattern.
How big is the pattern? Days of the week is the pattern 7. How big's the pattern here? How? 4. Once you hit 4, they repeat. Okay? We have I, which I wrote I could have said square root of -1, then -1. So what's I to the 8th? Because it's the same as I4 times I4, which is 1 times 1, which is 1. Okay? So what you need to understand is the cycle of I is 4. That's how long the cycle is, 4. Okay? So, again, think back to days of the week, okay? Let's try this one more time before I actually do this problem. What day of the week is it going to be in 50 days? Got to know your times tables. 50 days from now, what day of the week?
Wednesday?
Huh? How'd you get Wednesday?
That's 49.
Where'd you get 49 from?
7 times 7.
Yeah, now does it really matter that it goes in 7 times?
No.
What matters is that there's 1 left over. So really there's 1 extra day, which is a Wednesday, okay? So, when we look at 15a, we have I to the 43rd. Okay? There's definitely going to be a question like this on our next test, okay? Now, what are we going to, now with the days of the week, we divide by 7. For I, we can divide by 7?
4.
We're going to divide by 4, huh? So, divide by 4, and what do we get? I mean, it doesn't matter, what number close to 43? 40. So that's the same as I to the 3rd. Because every time we, think about this, put this on hold. Every time we add on 7 days, where are we at? Same day of the week, whatever day of the week, same day. Add 7 more days, add 7 more days, add 7 more days. Every time we add on 4 to this, or subtract off 4, any multiple of 4. So what we do is, take off, what's the closest multiple of 4 by 40? 3. I just said it, jeez. 40, okay? So chop off 40 of these, you're at I to the 3rd. And what is I to the 3rd? It's negative I. How about B? I to the negative 20th. Okay. Forget the negative for right now, just ignore the negative, okay? What number really close to 20 does 4 go into? I'm kind of giving you the answer. What number close to 20 does 4 go into? 20. It goes in 20. So chop off 20, or actually since it's negative, add on 20 of them. So it'll be I to the what? Add on 20 to this. To the 0. What's I to the 0? What's anything to the 0? 1. I to the 73rd. Now here's what I would do is this, okay? You don't need a calculator. You really don't, okay? If I asked you something like I to the 5,291st power, Actually, I tell you what, I'll learn you something new here, okay?
Learn
Yep.
something new.
You guys know the rules for like 5 and 10. What numbers does 5 go into? End in what? 0 or 5. What's the rule for 2? Goes into even numbers, okay? What's the rule for 10? Ends in 0. What's the rule for 3? You guys remember? Students always forget the 3 one. How do you know? Like, does 3 go into 507? Let's see. 579. Does 3 go into that?
Add them together.
Add them up. What's 5 plus 7 plus 9? It's okay.
21.
Okay. Does 3 go into 21? So 3 goes into that. How many times? I don't know. But it does. 3 goes into that. Okay. That's the rule for 3. That rule also works for 9. Okay. So does 9 go into that? No. Because what did they add to? And 9 doesn't go into 21. What if I did this? Does 9 go into that? Now it adds up to what? And 9 goes into 27. Now how many times does 9 go into that? I don't know. Okay, so that's the rule for 9 and 3. Okay, what's the rule for 4? Anybody know the rule for 4 to see if 4 goes into a number? It's a really simple one. I've never told you it before. Anybody think they know the rule for it? All you got to do is look at the last 2 digits. That's all you got to do. So if I give you 3,724, does 4 go into that?
Yeah.
Why?
And 24.
What about 24? So 4 goes into 24. It doesn't matter what the other numbers are. You just look at the last 2 digits, okay? So that's the rule for 4, okay? So here's what we could do. That's the same as I to the 91st. How did I get that? I'm only looking at the last 2 digits, okay? So give me a number in the ballpark. It doesn't have to be the closest one. It doesn't have to be the closest one. Just give me a number in the ballpark that you know that 4 goes into that's close to 91. That's kind of close to 91.
84.
84? I would have just said 80. 84 is even better. I'm going to do 80. Subtract off 80. Now we're I to the 11th. Give me a number that you know 4 goes into that's close to 11.
8.
Chop off 8 of them and you're I to the 3rd. So it's I to the 3rd, which is what? 95. Try a couple more, because there's going to be a question like this on your next test. How about I to the 2, 4, 8, 6, 9, 1, 3. Okay? That's the same as I to what power?
913.
Oh, I went too far. You're right. You're not wrong.
13.
Why?
Because it's the last 2.
All you got to do is look at the last 2. That's all you got to look at is the last 2 digits, okay? What number close to 13 does 4 go into?
12.
Chop off 12, you have what? I to the 1, which is? I. Let's try one more. Oh, we already did that one.
Yeah, we just did that.
So that's the same as what? I to the what power?
87.
So the 87th. Give me a number that you know that 4 goes into.
84.
84. Chop off 84.
Okay.
We got that now?
So you just
No.
look for the remainder?
All you do is look at the last 2 digits. That's all you do. Let's try one more. You're on the spot, okay? Look at the last 2 digits. I to the 2, 8, 9, 4, 3, 3. So that's the same as I to what power, Alexis? Sowers.
33.
Give me a number that you know 4 goes into that's close to 33. Well, let's come by 4. It's 4, 8, 12, 16. Well, 4 doesn't go to 6. No, let's count. It's okay. Let's count by 4s. Okay, we're just doing our times tables here. Times 4, 8, 12, 16, 20, 24, 28, 32, 32. Okay, just count by 4s. So chop off 32, you're at 1. Okay, is that sort of? Okay. All right, so this one right here. What's the number close to 73? She's off the spot now. What's the number that you know close to? And it doesn't have to be perfect. Just one that you know that's sort of in the ballpark. That's close to 73. That you know 4 goes into.
72.
You know what you could do? You know what 72. Could I have just said 40?
Yeah.
You should know that 4 goes into 40. You know that. So chop off 40. We're at 33. And this one I think 32. We just did 32. So that's I to the 1st, which is I. 17, I to the negative 46. Again, give me one that you know that that 4 goes into that's close to 46. 40? Okay, so let's, in this case, add on 40, because it's a negative, so it's I to the what? Negative 6th. We want to have a positive exponent, though, okay? A positive exponent. So, let's keep on, it's like, I want to make sure you guys understand. What's harder to tell me? The day of the week 700 days from now or 700 days ago?
700 days ago.
That's harder to figure out?
It's the same.
It's the same thing. It doesn't matter, it's just different direction, okay? So, just keep on adding 4. Add 4 to negative 6, where are we?
-2.
I want a positive, add up 4 onto that. I to the, and what's I squared? Negative 1. We'll make sure by the time the test rolls around, but you guys will have that down really, really well. Okay, we gotta keep going here. Number 19. Okay. I don't know if we talked about this or not in Algebra 2. You're not allowed to have you're not allowed to have radicals on bottom. You guys know that. You're also not allowed to have imaginary numbers on bottom, okay? So we have 3 over 2 plus 4i. Okay? So, what you do is you multiply the top and the bottom by the conjugate of the bottom. So we're going to times the top and the bottom by what? 2 minus 4i. Okay? So we do that. Let's distribute our 3. 3 times 2 is 6. 3 times negative 4i is negative 12i. And we said earlier, when you times conjugates, you just do your first and your last. Your outers and inners cancel. So we do that, we're going to have 4. Last 4i times negative 4i is negative 16i squared, which is positive 16. Okay? And then we have 6 minus 12i over 20. Now, that does simplify a couple ways, okay? What's one thing you can do to simplify this thing? Well, look at the numbers, 12, 6, and 20. Any numbers popping in your head when you see a 12, a 6, and a 20? What about 2? Goes in all of them. So you really should simplify it that way. 2 goes in here 3 times. 2 goes in here 6 times. 2 goes in here 10 times. Now, I don't care if you leave it like that, okay? But technically, it's got to be in, I erased it, A plus BI form, okay? You gotta be careful on this. Be careful before you say this. What is the real part here? But what is it? I mean, I have 3 minus 6i over 10. What would A be? What would the real part be? Huh?
3.
Not 3. You're close. You gotta be more careful. Not 3. That's not 3 there. That's not 3. Tell you what. That's not 3 there. It's what? It's 3 tenths. Okay, so you should be 3 tenths minus, what's the imaginary part?
6.
And 6i, can you simplify 6i over 10?
Yeah.
To what? 3 what? 3/5 i. That's the way you really should put it, okay? The real part, the imaginary part, and simplify it if possible. Okay. 21. 1 minus 7i, 6 minus 2i. Hate math? Nobody hates math. It's great stuff.
No, it's not.
Okay, so we can't have imaginary numbers on the bottom. Okay, you can have them on top, just can't have them on bottom. So we're going to times the top and the bottom by the conjugate of the bottom. I'm just curious, what do you think would happen? Could we multiply the top and the bottom by the conjugate of the top? Could we?
Yeah.
Should we?
No.
What would happen if I times the top and the bottom by the conjugate of the top?
Yeah.
Say it again?
No imaginary numbers on top.
And are we allowed to have imaginary numbers on top?
Yeah.
Yes, we can. You can do that, but you're still going to have imaginary numbers on bottom, and you're going to have to get rid of them. So it's a wasted step.
Wait, timesing the top and bottom right now by the conjugate will get rid of both imaginary stuff.
The conjugate of what? The conjugate of the top and the bottom?
Just the bottom. What are we doing the top and bottom?
No. We said we're going to times the top and the bottom of the conjugate of the bottom.
Yeah.
I asked, could we times the top and bottom of the conjugate of the top? Ugh, that's hard to say. And we can do that, but all that does is get rid of the imaginary numbers on top. We can have imaginary numbers on top, we just can't have them on the bottom. You're not gonna get rid of both of them.
Not here?
It's not gonna happen. I can't think of a situation where you could get, if you have imaginary numbers in there, I don't know. I'm not sure if you could get rid of both the top. I mean, there's imaginary numbers there, there's imaginary numbers there. You can't get rid of, you can't just say, you can't just erase them, okay?
Yeah.
So, let's times by 6 plus 2i on top and bottom. I mean, that's kind of like saying,
Oh, I see, because I thought at first I was forgetting, we were still doing FOIL, it's just
Right.
on the bottom, since it was saying we're doing only the first.
I think what you're doing is possible, but it's not allowed, because we've learned from day one in algebra, whatever you do to one side, do to the other. There's a couple rules though they can't do. If I give you 3x plus 4 equals 7x minus 9, can I times each side by 5 if I wanted to? Can I times each side by whatever number I want? There's one number you're not allowed to times by. Why?
Because then it just,
Everything goes away.
yeah.
If that was allowed, algebra would be so easy. Every problem would say 0 equals 0. Times everything by 0, done.
No, I
So,
was forgetting that you only, do FOIL different if, it's a conjugate.
oh, yep, no, yeah, these are, you gotta do the whole FOIL here. Here's just the first and last.
Cause it would cancel out the 7i, but then it would make a new imaginary number.
Right. So let's do the bottom. So we're gonna have 36, negative 2i times positive 2i is negative 4i squared, which is positive 4. Let's FOIL out the top. We're gonna have 6. I'm gonna skip a step here. My outers are 2i, my inners are negative 42i. A negative 42 and a positive 2 is a negative 40i. And our last, negative 7i times positive 2i is negative 14i squared, which is positive 14. Okay, we can clean this up. 14 and 6 is 20, minus 40i over 40. And mentally, let's break it up and also simplify it. The real part, unsimplified, is 20 40ths. But what is 20 40ths? 1/2 minus, what's 40 40ths? 1i. A half minus 9. Okay. Like I say, we're gonna go along today here, guys, because like I said, I want to get through as much of this as I can today, so you guys can work on this over the next 5 days. Not that you have to spend 5 days on it, but any of the 5 days. Okay. So negative 4 plus 6i over 2 plus 7i. So again, we're going to times the top and the bottom by the conjugate of the bottom, which is 2 minus 7i. If we do that, let's do the bottoms first. They're easier, the conjugates. 2 times 2 is 4. My last 7i times negative 7i is negative 49i squared, which is positive 49. Let's FOIL this thing out. My first is negative 8. I'm going to skip a step here. My outers are negative 4 times negative 7 is 28i, positive 28i. My inners is 2 times 6 is 12i. 28 and 12 is 40i. And my last, 6i times negative 7i is negative 42i squared, which is positive 42. Put together 42 and negative 8, that's 34 plus 40i over 53. And again, on a test, I'm not going to take points off. If you're taking a college class, they might take points off though, okay? A better answer would be what? The real part's what? 34 50-thirds plus 40 50-thirds I. The real part's 34, and that doesn't simplify. Okay, let's do an easier one now.
No. All of our.
Okay. All right, so 25. We have 4 minus 2i. This one's an interesting one. I'll see what you guys have to say about this one. Okay, this is an easier one. It's definitely easier. What do you guys think we need to do? I mean, we can't have the I on bottom, so times the top and bottom by
Actually,
5i.
5i or negative 5i?
5i.
Tell you what, what's bigger? 10 over negative 2 or negative 10 over positive 2? They're the same. It doesn't matter where the negative is. So do you times by 5i or negative 5i on this one? Guess what? It doesn't matter. It really doesn't matter, okay?
Oh, yeah, because you can, okay.
In all honesty, you don't even have to times by negative 5i or positive 5i. What you really just need to times by is I. Let's just do I. I'll show you why. What's I times I? And what's I squared? Negative 1, which makes negative 5 what? 5. Times all of this by I, we're going to have 4i minus 2i squared.
Why not keep this simpler so you get all the numbers big?
Yeah, it is a little bit simpler, yeah, because rather than timesing by 5. Okay, and what is negative 2i squared?
2,
So 2, what's our real part then?
2 plus 4i.
Well, I'll write 2 plus 4i over 5. So what's the real part? 2/5 plus 4/5 i.
So if we could times by I in this case, because it was only the 5i.
Mm-hmm. Now if it was 5 plus I,
Well,
you'd have times by 5 minus I.
Well, on the previous one, for example,
Mhm.
would you have times by 2 plus I? No, it'd be
No,
2 minus
no,
I.
no. The only time, basically, I don't want to say this.
Is when it's
You
I
have to
goes
times by the conjugate when you have a binomial, when you have two, something plus something or something minus something, okay? If it's only a monomial, just times by I,
up.
okay? So it's the same thing with radicals. If I gave you 8 over 7 radical 3, you times the top and bottom. You could times by 7 radical 3. I just times by radical 3. Now if it was 7 plus radical 3, you have to times by 7 minus radical 3. Because then it's a binomial, it's 2 terms. Okay, a few more. All right, this one's not any more difficult, just takes a little longer. 2 plus 5i to the third. So 2 plus 5i times 2 plus 5i times 2 plus 5i. We've already talked about this. You cannot multiply 3 things all at the same time. It's impossible. So let's do them 2 at a time. Okay. Is this going, hopefully? Good. All right, I'm going to do these last 2 first. We're going to have 4. My outers are 10i, my inners are 10i. Together that's 20i. And my lasts, 5i times 5i is 25i squared, which is negative 25. Put that together, we're going to have 4 and negative 25 is negative 21 plus 20i. We still have to times by 2 plus 5i. Got to do it again. So, if we do that, our first terms, 2 times negative 21 is negative 42. My outers, 2 times 20i is 40i. My inners, negative 21 times 5i is negative 105i. And my last, 5i times 20i is 100i squared, which is negative 100. Remember, it makes it negative 1. The real parts, negative 42 and negative 100 is negative 142. The imaginary parts, 40 and negative 105 is negative 65i. Okay.
This seems like it's going to be easier than the last section.
Oh, I think it is. I think it's definitely easier. Okay, let's do an easier question yet. Don't write down number 29. Don't write it down. If you did, it's okay. But it says 2 minus something. Don't write radical negative 4. What's radical negative 4? What's the square root of negative 4? What's the square root of 4? 2. What's the square root of negative 4 then? 2i. 3 minus, what's radical negative 16? Well, radical 16 is 4. What's radical negative 16?
4i.
Now what do we do? FOIL. Okay. So we're going to have 6. Our outers are negative 8. My inners are negative 6. That's negative 14i. And my last, what's negative 2i times negative 4i? Times, don't add, Quit timesing.
Or 8I squared.
Okay, so positive 8I squared, which is negative 8. So the real parts are negative 2, that's 14I.
Why,
Skip 31.
why did?
31 and 32, cross them off.
Why did we put, i's after once we were done simplifying the radicals?
Because they are. Radical negative 4. Radical 4 is 2. Radical negative 4 is 2I. The square root of a negative is imaginary.
Oh, yeah.
That's what this lection's all about, man. So, 31. And it's not the 31 and 32 already. We've done 31 and 32, we've done it to death. Just cross them. Don't even do 31 and 32 at all. 33. So people at home, cross off 31 and 32. 33. Don't write down the problem. Don't write down radical negative 36. Write down what? 6? 6? 6? 6I or yeah, 6I. Okay, there's nothing in between these. So what do we do with multiply? What's radical negative 49? 7? I over. What's radical negative 16? 4I. So we times the tops, we're going to have 42I squared over 4I. Now here's what you could do. I don't want you doing it though. We're going to do a shortcut here. You might go 42I squared is negative 42. You could do that. Okay? Don't do that though, okay? Here's why. Is our final answer going to be okay? No, why? I on bottom. So let's do this. Where are there more i's? On top or on bottom?
So is it 42I over 4?
Well, does 42 fourths simplify?
Yeah.
To what?
Only 1 over 3.
Okay, 2 more to go. And I'll tell you what, on the back, do me a favor here. We're not going to get through all of this today, but we're going to get through an awful lot of it. Cross off on the back. We're still got 2 more problems to do. Cross off 49 to 62. We're not doing those. We're going to go as far as 48. Okay? So the last we're going to do is number 48. Okay? Okay, 2 more to do. And I don't know why students struggle with these. So the last 2 that we're going to do here, 35 and 37, then we're done for today, okay? So what we'll do on Monday when we come back, we do have a homework quiz on Monday. Monday when we come back, I'm going to do those, 39, 41, 43, and 45, and 47. Those, they won't take long, okay? And then, so I mean, don't wait until Monday night, especially if we have a basketball game or a wrestling meet or something Monday night next week. You know, work on these a little bit over these next 5 days. Okay, when we get to 35, don't even look at that yet. I want you to understand this. If I give you this right here, 7 over 8 equals, any idea what that box has to be?
7,
How'd you get that so easily?
because 7/8 has to equal 7/8.
Right. Now, let me ask you this. You're still up, Luke. What's the answer? Very good. Why was sake? What's the problem?
The denominators are.
If the bottoms are the same, doesn't it stand to reason that the tops have to be the same? And the stuff that are in the same spots needs to be the same. They got to be the same, okay? So, we're only going to do 2 of these here. I would just watch number 35. Just write down 35, then watch it, okay? So we have 4 plus, parentheses, x plus 2i, I equals x plus 2i. Okay, write it down, then just watch. Okay? Now I'll give you time to write this down. It's going to take you longer to write the problem down than it's actually to show the work I'm solving, okay? There's 2 parts here. There's this part and that part, and there's this part and that part. Is this real or imaginary? Why? Why is it real? There's no I. Is this real or imaginary? Imaginary. Why? What's this? Real? Imaginary. So here's what you do. Set the real part. You're asking you to solve. They're asking us to solve for x, y, and I.
No.
They don't solve for the variable. Which variable don't we solve for?
I.
Good. Why don't we solve for the variable I? Listen to what I said. I'm saying very carefully. Why aren't we solving for the variable I?
Because it's a variable.
Huh?
Because it's a variable.
You're totally wrong.
Because of that answer,
Because it's imaginary.
I's not a variable. It is not a variable.
It's a number.
What number?
Negative.
Not -1.
Good and negative.
the square root of negative 1, okay? I is not a variable. It's a number, okay? So, set the real parts equal to each other. What's the real part over here? 4 equals, what's the real part over here? How do you solve that for x? You just did, okay? Now, we all done? No, we have to solve for y, okay? So, set the imaginary parts equal to each other. What's the just leave the I out. Leave the I out. What's the imaginary part over here if you leave the I out? X plus 2y equals, what's the imaginary part over here if you leave the I out? 2. But what do we now know? Is what? So what do? Subtract 4. 2y is 2 minus 4 is negative 2. Divide 2. All they're saying is if x is 4 and y is negative 1, that's a true statement. That's all we're doing. It's just like anything else in algebra. When you solve it, they're saying what makes a true statement. It's no different than this. When I write this up here, without even asking anything, what are you guys thinking right now? Why 6? What's so special about 6? When you plug it in,
6 plus 1.
it's true. Why isn't it 4? When you plug in 4, it's not true. All that is asking what makes a true statement, okay? 37, last one. I'm not going to write the problem down. What's the real part on number 37? On the left.
2x minus 1.
Good. How do you know it's not imaginary? 2x minus y equals, what's the real part on the right-hand side? How do we solve that? This goes back to algebra 2. How do we solve that? We can't. 2 variables. We need 2 equations. What's the imaginary part? Ignore the i's. What's the imaginary part on the left?
Negative 16.
Negative 16 equals, what's imaginary on the right? Ignore the i's.
4y.
Okay? That can help us much?
Yeah.
Sure. What are we going to do? Which one are we going to use? The first or second one? Divide by 4 and you get what? What's negative 4?
Y.
Plug it in. 2x minus 4 is 10. So plus plus, subtract 4. 2x is 10 minus 4. Whether you realize it or not, we're not doing anything different than what we're doing with Luke here. We're putting the triangles or the boxes and saying, what do they have to equal? The real part has to equal the real part. The imaginary part has to equal the imaginary part. That's all it is. Okay, so again, you need to work on section 1.4. Homework quiz on that is on Monday, at the end of class Monday. You're not going to have time to work on 1.4 in class, though. Well, you might. Okay, so what I'm going to do is this. When we come into class on Monday, I'm going to finish up these last 4 or 5 questions from 1.5. It's probably going to take 10, 15 minutes or so. And then whatever time's left, you can work on this or 1.4 if you need to, but we're having the homework quiz over 1.4. And when is the homework quiz over this? Tuesday, okay? And just real quick here. When you look at numbers 39 through 45, they're not going to factor. So if you really want to solve them, how are you going to solve them if it doesn't factor? Is there any formula we ever learned that helps you solve quadratic formula? That's how you're going to do it, quadratic formula. Okay? All right, so if you want to work on those on your own, it's the quadratic formula on the little back. Oh, is it time? Shoot. Okay. All right, have a good 5 days off, guys. Are you done with 1.4?
No, I
No?
think we've done a few of them. I was gonna come see you
Oh,
earlier,
okay.
but
Just email me if you need help.
Okay.
Or I can help you on Monday too, either way.
either way, there's like a few of them.
Gotcha. Uh-huh.
Why do you have to do
By what?
why do you have to do 4 for like the I? You know what I mean?
Oh, because that's what it is. That's when it starts repeating. After we do it 4 times, if I give you this, I is the square root of negative 1. That's the definition of what I is, the square root of a negative 1, okay? I squared is negative 1. Remember those are the first 2 things I do right now. I to the third is the same as I squared times I, okay? Just like x to the third is the same as x2 times x, okay? Well, I squared is negative 1. Negative 1 times I is negative I, okay? Negative 1 times I to the fourth is I squared times I squared, which is negative 1 times negative 1, which is positive. Now, if I said I to the fifth, it's the same as I to the fourth times I. I to the fourth is 1. 1 times I is I, okay? I to the sixth is I4 times I2. Well, I4 is 1. 1 times I2 is I2, which is negative 1. I7 is I4, I3. 1 times I3. I3 is negative I. If I kept going, it goes a little bit farther. I4, I8 is I4 times I4, which is 1 times 1, which is 1. Because that's when it starts repeating itself. If I went to I9, I9 is the same as I8 times I. I to the 8, we just said was 1. What's 1 times I? I, negative 1, negative I. This is I, negative 1, I, negative 1, negative 1, negative I, positive 1, positive. That's when the repeat. Just like the significance of 7. That's how many days. Oh, we're on video this whole time. That's how long the repetition is. That's why when I say days of the week, you go 7 times into it. If I asked you what month will it be 13 months from now, you'll say it's going to be March. Okay, because it's February now. What's the magic number there? Not 4 or 7. It's 12. Okay. All right. I didn't mean to put you on the spot. I just want to make sure you got
it's
it.
fine.
Who's your brother? I
And
do it all the
please,
time.
could Colby Roberts and John Hyatt